Hi, welcome to monitoring module of MLOps Zoomcamp. You already learned how to develop a service on top of machine learning model and how to deploy it in production. This is a great thing. Now let's make a next step and discuss how to monitor machine learning models in production. Actually, this makes a lot of sense because when machine learning model operates in production environment, it already generates some value and each failure costs us something. So we need to make sure that our model operates exactly as we expected. Let me quickly introduce myself. My name is Emily Zhao and I am CTO and co-founder of Evidently AI. At Evidently, we build an open source tool to analyze, validate, and monitor machine learning models in production. We all know that there are a lot of things that may affect models' quality in production. In most cases, when something is wrong with the model, that's because the data is wrong, and there are a lot of issues that might affect input data, starting from data processing issues till the physical data loss at the source, for example, when the physical sensors are broken. Together with data quality, the environment in which model operates can change. For example, the input feature distributions has changed, or even target function can change itself. Those concepts are well known as data drift and concept drift. So at some point, at some moment, model's quality can decrease, and we need to detect this moment in order to intervene and do something. For example, retrain our model or entirely rebuild it, maybe fall back to some rule-based system, but with help of some process, we need to detect that moment and fix our model. So how to prepare for it? By monitoring. And one can say, okay, we have production services for ages. Why can't we just take the existing monitoring schemas and just apply it to ML-based services? So actually we can, but there are some extra layers to look at, and this is the data health and model health. But let's quickly observe what to monitor. And I want to say it straightforwardly again, we need to monitor for service health because we are talking here about production services. Of course, the exact monitoring schema and amount of metrics heavily depend on the way how you deployed your model, and batch machine learning models really depend from the online serving model which operates, for example, under high loads. So amount of metrics will vary, the monitoring architecture will vary itself, but anyway, we need to implement service health monitoring because we need to know does our models actually works. Secondly, we need to implement model performance monitoring to answer the question how model performs. The exact amount of metrics heavily depend on the problem statement. We all well know quality metrics for classification, for regression, for recommender systems, so it depends on the problem statement. There is only one thing I want to specifically mention there. This is the feedback. Because if you have an immediate feedback, you're really lucky. You can straightforwardly calculate any quality metrics you want, and that's it. But if you have a delayed feedback, and this can happen, for example, if you work with some forecast service like users' churn prediction, when you need to predict which users are going to leave your service. Generally, you want to make this prediction in a month or even a couple of months in advance. Then, in order to calculate any quality metric, you need to wait while this time has passed in order to get these true labels and calculate these quality metrics. And the problem is that during this period of time, you might actually apply the same model several times more. And if there are some issues or failures, you will just multiply the amount of this. So we need to monitor some extra metrics in order to make sure that everything is more or less okay with our model. So what can it be? Data quality and data integrity, of course, because if there are some changes in data quality, or if even data drift or concept drift has happened, then probably our model can start decrease in quality. So these are basically 4 standard things that we monitor for machine learning models in production. Of course, you do not limit yourself to all these 4 things, and you can add additional metrics. It always depends on the sensitivity of your case and on the risks you're eager to take. For example, if you work with some pretty sensitive problem statement, you might want to specifically monitor for some segments. For example, it can be new users or users from some specific regions. And in this case, you can just separate those segments and calculate all the metrics for it specifically. If you work with some sensitive service in, for example, medicine or social, you might account for model bias and model fairness. If each individual error costs you a lot, you might implement the outlier detection. In this case, if you can detect your outliers even before you applied your model, you can consider sending your object to some alternative ways, for example, role-based systems or even individual manual review. Finally, if you share with your users some information about explanations, like why your system decided to show these or those recommendations, often it's implemented in order to generate some trust, then you might want to monitor for explainability as well, especially if you retrain your models automatically and you need to make sure that explanations are still relevant. So now we know what to monitor, and let's discuss how to implement the monitoring. And here I want to touch the batch and online serving models approach. Generally, if you have online serving model, you want to implement online monitoring, and if you have batch model, you want to implement batch monitoring. But there are some exceptions here, and I want to quickly mention it. So let's start from the batch case. Most of production machine learning models operates in batch. This means that you might have your pipeline operates with help of workflow manager like Prefect or Airflow. In this case, you typically want to keep your monitoring batch as well. Basically, you may add some calculation block after each step of your pipeline and run some checks to make sure that your data and model behave exactly as you expected. In this case, it will be a perfect solution. So you might want to calculate some metrics after specific steps. Then you can log this data into NoSQL or SQL database and add a visualization layer. For example, each time you get a new batch of data, you might build a visual report with help of some tools like BI tools, maybe Tableau, Looker, or customly implemented. Evidently also allows you to build a visual report in HTML format. When it comes to real-time serving models, you probably might want to keep a closer look on how your service operates, and in this case, you might want to calculate quality metric very often, and you might want to get a service that pulls metrics in real time and in real time update your dashboards. In this case, Prometheus and Grafana is a good combination, because you basically need a system that can pull metrics from your application in real time and update your visuals pretty often. And you even might want to add some alerts, and Grafana is a perfect solution for that. Sometimes, even if you have online serving model, you might want to keep monitoring batch. It makes sense for a lot of metrics, and data drift is a good example of such metric. There is no need to update your data drift estimation after each new rows of data, right? You basically want to collect some batch of data first and then calculate drift. So if you do not need to get real-time updates on your model's quality, you might implement the monitoring for your real-time serving model in batch way as well. Now it's time to practice, and before we move to some Python code, let's quickly discuss the architecture of projects we aim to build. You have already implemented a very nice prediction service in the previous module, which predicts the duration for roads on top of taxi data. This is a great job. You even implemented the service in different ways, and now we can monitor the services. Great thing. So let us quickly discuss the architecture. Now you have a service that takes the JSON input data and gives you the JSON output with the duration. That's nice. Now let's add some additional things to implement the monitoring for this service. And let me just quickly introduce this. So in order to implement monitoring, we need to simulate the production usage of the service. So we need to give a lot of data to the service in order to give a lot of outputs. Let us quickly write a Python script that will simulate production usage. So we will download an additional batch of data, New York taxi data, and we will write a Python script that will analyze this file row by row and send those data to our prediction service. Our service will analyze this data and make some predictions. Now it's kind of production service, and we need to log the model application, right? So for this case, I suggest us use MongoDB and store there our JSON inputs and predictions that our model made. There are many different databases we might choose, and I want to quickly comment why we will use MongoDB for logging. Actually, there are several reasons, and first is that our data has JSON format. Basically, it's unstructured data because the amount of fields can change in a JSON, and MongoDB is a pretty good solution for it because it's no SQL database. So basically, you can create collection and you can push the documents, and these documents might have a different structure. So sometimes you might have more fields, sometimes less, and it will be working pretty well in the same collection, which is like analog of table for SQL database. In order to push our data to MongoDB, we need to connect to host, create a database, create a collection, and push our data there. For doing this, MongoDB have a very nice client library implemented in many programming languages, and happily it have a client library implemented in Python, so we will be able to easily communicate with MongoDB. And in case we only need one single instance on MongoDB and we don't really care about security, we can do it comparably simple, so this is the perfect choice for our example. Second thing is the monitoring. So we need to implement the online monitoring. So we need to send the data from our prediction service to monitoring service, which will calculate the metrics, place these metrics in Prometheus database, and this Prometheus database will share these metrics with the Grafana service. So we need to update our prediction service with basically two extra instructions. First instruction to log data into MongoDB, we just discussed that, and second instruction to push data to monitoring service. This monitoring service will calculate metrics. This helps us evidently, and then this prediction service will expose the HTTP endpoint and place metric in Prometheus readable format. So Prometheus will be able to go to this endpoint and pull the metrics. Why we choose Prometheus there? It's a very nice solution for online monitoring. If you need to frequently take the application logs and update the visuals, you want to get the system that can frequently pulls data from your application. Prometheus is the great solution for this because it pulls data from the endpoint, and again, Prometheus has very nice client library in Python as well, which help us to expose this endpoint and process metric into the format that Prometheus can read. So after the Prometheus gets data from the endpoint, it's stored in the locally implemented database, and this database is very nice optimized for working with the frequent data. So it's very nice optimized for time series data. Also, I want to mention that Grafana and Prometheus are very well integrated. They have direct integration, and Grafana can use Prometheus data as the data source. In Grafana, we can create very nice visualizations, plots, charts, histograms, so we can visually analyze our data and see what is happening there. Maybe it makes sense to add that Prometheus actually also have some visualization tools, so you can plot some graphs directly in Prometheus, but in Grafana you can create really a lot of different visuals, add some alerts, so often they are used all together, and both Prometheus and Grafana are open source. As I mentioned before, together with online monitoring, we can create a batch monitoring. So let us implement this in our example too. So you will be able to analyze both architecture, compare, and decide what you might want to implement for your production machine learning services. We already implemented a login with help of MongoDB. Why not to use this data to implement batch monitoring? We already learned a prefect workflow manager, so we can create a perfect flow, which will take data from our MongoDB. It will take JSON inputs, JSON pret, and target actually, which we will separately place in our MongoDB with help of just simple Python script. We can implement a prefect flow, which will take the data, load the data from MongoDB, then calculate model profiles, basically a lot of metrics, which we can easily calculate with help of Evidently. In this case, Evidently will serve as just a calculation layer, and send those profiles back to MongoDB. So this is how we implement the batch monitoring, and together with JSON profiles, we can create very nice visual reports and just share it with the users. So we will also do it with help of prefect job. So that's basically two different monitoring implemented for the same service, a batch one and online one. And generally in the real life, you rarely implement both monitorings for the same machine learning based system. Actually, you can, because you might want to calculate some metrics in online form, some metrics in batch, some extra metric, and in this case, you might have more or less the same architecture. But generally, you might want to have either batch or online monitoring. So now it's just an example to demonstrate you a lot of different possibilities, right? You can see that there are a lot of services that need to communicate with each other, and in order to create a container for each service and manage their communication, we will use the Docker file. I know that everybody probably knows and like Docker, me too, so we will use it in order to make sure that our services works well together. So now it's time to go and observe some code. I just opened a GitHub and let's observe what we have here. So deployed a machine learning model as the service. That's great. Let's open and see how it's implemented because we are going to update this service. So I go to web service and I can see some utility files there. And yeah, that's README, that's linear regression model, which predicts the duration of roads, that predict.py file, and test Python script. So the service implemented in predict.py script, let's open it and see what we have there. So great. Service is implemented with help of Flask. So it takes the model, it takes the input data, the process it, and with help of predict method, it returns the JSON. Great. So we will use this service, we will take it, and we will update it with 2 more instructions. So in order to simulate production usage, we need to send a lot of data to this service. So we need to log it somewhere. We will add a login there, and we need to send this data to monitoring service. So we will implement the sending data to monitoring service as well. So let's take the script and update it. And let me quickly go back and open up a monitoring folder. So here you will see the structure more or less the same as what we observed on slides. In the second video, we will discuss the structure of monitoring project in more details. But now let's see what services we have there. And we have evidently service, that's basically monitoring service implemented with help of evidently, and the prediction service. Go to prediction service and implement their UpPy, the Python application that will make the duration prediction for us. So let me go now to the deployment folder back. I just wanted to show you the place where we will implement the prediction service. Now let us open up the existing implementation. And based on this implementation, we are going to create our UpPy, our Flask application. So I just created the UpPy script. That's the Python file, an empty one, and I place it inside of prediction service. And I also have a Docker file here. I also copied the linear regression model, and there are some requirements there. So now we need to implement our application. So let's see which libraries were used there. It's Pickle and Flask. You will need those as well. And I will import OS library as well because I need to use it. So let us import things. Import no OS. Let's import, what else? Pickle, right? Probably we will need a request to get data and send the some data to the services. So let's get requests and Flask, of course. So we need some models from Flask. Let me check again which ones. Flask, request, and JSON file. Perfect. So let's just write from Flask, import Flask, probably request, and what else? And JSON file. Yeah, probably that's JSON file. Okay, probably that's all libraries we need to import there. So next we will need to read the model, but before actually we write this code, I suggest us to create a couple of constants that we will reuse during our work in our service. So let's create a global constants. So this will be a model file, right? Because we need to work with model. We agreed that we need to send our data to database. So let's create a variable with the database address. It's Mongo. Let's call it just MongoDB address. MongoDB. So we need to basically import PyMongo, right? Yeah, let's write it from PyMongo. Import, we need client, so import Mongo client. So yeah, now that's it. And one more, we need to send our data to online monitoring service. So let's create this evidently monitoring service address. So I will just call it let me hit the caps lock. Let me call it evidently service address. Yeah, nice. So now let me create the variables. I will use OS to make it. So let's check. Let's select a name. This should be a model file. Yeah, I will keep the same name. Model file, and my address will be the name of the file. That's linregbin. So let's just linear regression.bin. So now I can reuse this construction, and whenever I call model file, it will give me the path to this linear regression bin file because I use getenv there. So now let's again use getenv, and now just let's keep the same name, MongoDB address, right? So let me just copy it, and the path would be our MongoDB. So that's the local host. So I just write this standard address, and I should have a port, but I don't really remember. So let us quickly go to Docker file and check the port where we're supposed to have our MongoDB. So I go to monitoring folder, and my Docker file can help me with that. We will discuss the structure and content of the Docker file, but now I will just quickly go and see where we're supposed to host our MongoDB. It's the last one, and yes, that's the port. So let's just copy it from there and put it right there. So now we know where we are going to host our MongoDB. And last is the evidently service. So let's create, let's go getenv again. So here the variable name will be evidently service. I prefer to keep two words here. And again, the address. So now it will be localhost. So http / or you can just write localhost there, but I prefer to keep it like this. And one. Oh, an extra, and here as well. And the port will be 5000. This one I remember well. And let's keep single brackets everywhere. So probably that's it. Now we have all the needed variables, and now let's read our model. Let me quickly go back to the existing service implementation because there were such instructions, and I just wanted to copy it. So here we do it with help of pickle. Let's do the same, and let's substitute this with our global constant for model file. Just model file here, and I don't really need to have a tuple, so I will just remove a bracket here. So now we read our model. Right, good. So now let's create the Flask application again. So I create the object app application. This will be my Flask application, right? And let's call it duration, if I'm not mistaken. Duration. Yeah, because we predict the duration for routes. So then we need to create Mongo client, right? Because we are going to log our data into Mongo database. So our Mongo client. And we already imported Mongo client from PyMongo. Let's use it. Mongo client. And let's pass here Mongo address. Luckily, we already have the variable for it. So I will just put it right here, MongoDB address. Good. So now let's create a collection and database. We start from database, DB, and yeah, we already have Mongo client. Yep, so let's call method getDatabase, and let's call it prediction service because it's database for our prediction service. So it's prediction service. Yeah, now we have a database, and now we can create a collection like a table in our database. So our collection is equal to database, right? And we call getCollection method. It helps getCollection, and let's call it somehow. Let's just call it data. Maybe we will rename it later. So that's our collection where we will store the input data and model paths. So that's it. And now we can start implementing the Flask application itself. So we need to implement method to process our input data. And you know that we need to use decorator here. So let's just write it. It's up road, right? So we already used it in the previous module. And we need to get to write the name for our function here. So it will be predict, because not function action, right? It will be URL, our host /predict. And we need to select methods, and it will be post. And because we use this HTTP method, so it will be post. Now our function, let's define predict, right? Yeah, if I'm not mistaken, it was just predict, right? And now let's check what our predict function should do. So let's go to predict endpoint. Okay, we were close. So we need to get the input data, get JSON from request, and then there are two functions, prepare features and predict. Let's see quickly what they do. So here, yeah, we create the dictionary, we calculate extra function. Okay, so let's repeat this logic in our application, but I would better do all this job inside of predict method, because I just want to keep a less number of functions, because we are going to implement 2 more functions to save our data to database and to send the data to monitoring service. So first we get JSON. So let me just copy this from here. So I will create the record here and just to repeat the same instruction. Now we have our input data. So next we'll be calculate some features. So I will update it, or let me just quickly copy it from here. So I create PUDO function exactly as you did before. I will just copy this instruction in order to save some time. So what else should I do? I need to do some transformation, because it's the next method. So let's calculate the features in the way model can process it. So we do transform our features, but we do not have features, we have record. So let's just do it right there, record. And if I'm not mistaken, this method expects the list. So let me do this. Okay, now we have transformed features, and probably we're ready to call the prediction method. So let's do it. Ypred, we call our model predict method. Model predict, and we get this prediction. So yeah, basically that's the logic of calling the prediction. So what else? Now we need to return the JSON output. Let's do it. So our result or output will be a dictionary. And there, what should we do? We should select the K, let it be duration, because we predict duration. And the value will be a float from our prediction. Yeah, probably that's it. And basically, we need to return this value, but we decided to save our data to a database and to send it to monitoring service. So let's do this. So for now, just declare our intentions. We do not have a function yet, but let's just create it. Save to database something in order to add all the logic to our predict method, and send to intently service again something. So now we will not forget about it. And what we return here, we return just JSON. So return JSONify our result, right? So That's it. So that's basically the logic. Now we just need to implement this save to database and send to evidently service functions, and that's it. Now our predict method get the data, perform some simple preprocessing in order to calculate additional feature, preprocess data, call the model, create the Python dictionary with the output, and return it. Together with this, we save this data to database and send it to evidently service. So now let's implement to this function def save to database, right? Def send to evidently service, right? And in order to make our application work, we need to add some instruction about the uprun. So let me just copy it from there because it suits us well, right? It's the same thing. Again, debug mock true, right? Host, yes. And port suits us pretty well. So now we need to implement 2 extra functions and we are good to go. So let's start from save to database and let's quickly remember what we want to save there. So we need to save input data, mainly our record, and we need to log our prediction. So let's just call it prediction. And actually same is true to sending to evidently service function. So that should be like this. And what should we start from? First of all, let's create the record, which we are going to save. We are going to copy all the fields we have in our record, initial one. So let's just record called record copy. So now we have all input data and let's add there our prediction. So I will call it prediction. Prediction, and I add the prediction we get from here. Prediction. So basically that's it. We copied all input data, we added the prediction. Now we're ready to push this to our MongoDB, and luckily we already have our collection ready. So let's just call it from here, collection, and let's insert 1 row. So we just call method insert 1 and use our rec here. So basically that's it. And now let's copy the arguments to our function because actually we need it right here. So yes, it works, and let's make sure that we have the right names, record, yeah, and prediction. Good, very, very good. So now let's implement our last function, send to evidently service. Here we need to send the same data, so basically we can just reuse it right there. Good. And now let's implement the logic. So again, we need to create the record, right? So let's just reuse these 2 instructions because we need to actually send the same data. And now logic to sending data to evidently service, this can be implemented with help of requests because we need just to use the post method to send the data. So we call our requests. It helps, good. Then post. It's the first one. And where to post? We are going to post it to evidently service, and we have very nice variable to this, evidently service. Yeah, I need to know the correct URL. So let us quickly go and see how our monitoring service is implemented because I'm not sure I remember the correct spelling. Yeah, so I will go there and I will see where I should post my data to evidently service. So I go to UpPy here. It's loading. And let me quickly see where I can send my input data. So I go into Flask application. I'm doing it fast because I already know where to look for it. So I'm looking for this uproad function, iterate dataset. So let me copy it. Iterate dataset, and my dataset is called taxi. So it will be here like extra slash iterate dataset, and my dataset is called taxi. Yeah, taxi. So now let me create the correct string. I'm using Python 3.8, so I can use strings. Yeah. no, like here, and this is variable, so I need to use brackets. Yeah, now this looks correct to me, and the data I'm going to send, it's JSON, and it's record, because I already created record. Yeah, now it looks nice to me at least. Evidently service address iterates taxi, JSON record, post. Yeah, that's it, and basically that's all. So I implemented two additional methods, saving to database and sending data to Evidently, and it should work. I can see that there is still some issue. We forget to update send to Evidently service function with the right arguments. Let's do it. So we just copy it from the previous function and placed it there. So now everything is fine. Let's save our data again and move to the terminal. I opened up my terminal, I moved to the monitoring folder from the same repo, I cloned it already, and now let's check whether we updated our application in the right way and whether it actually works. I need to mention that we updated our application with two extra commands, and now it should interact with the MongoDB and with the Evidently monitoring service. As we discussed at the very beginning, we will run all these services with help of Docker container, and now I want to quickly jump like in the future and run our Docker Compose. We will discuss this Docker Compose in details in the next video, but now we just need to make sure that we updated our prediction service right, and we have a service to set up monitoring for. So let's quickly run all the needed container with help of Docker. I will just write Docker Compose up, and let's check that our application works. So I write Docker Compose, it creates a lot of containers, it's MongoDB, it's prediction service, it's Evidently service, it's Grafana, it's Prometheus. Yeah, Prometheus is there. So we can see that everything is successfully running. I cannot see Grafana, let me quickly go and yeah. Grafana is there. So probably now everything operates and we can check our application. For doing this, let's go to prediction service. Here is our app.py implemented, and we had the script test.py. Let's quickly see it. It's called test.py, where we use the URL of our service, right? That's the one road, one write, with some features. And what we are trying to do here is just send this single write to our prediction service and print out the response. So let's try to do that. We write Python test.py, and if we implemented everything correctly, it should work. Yeah, so it gives us the prediction, at least the prediction part works correctly, and we hope that now we saved one row of log to our MongoDB and sent it to Evidently prediction service. At least there is no errors there, and later on next videos we will explore how this data looks in our MongoDB and how Evidently service processes this data. Now we finished to update our service. Let us quickly move back to the picture of our architecture and discuss once again what we did. We took our prediction service and it added the connection to MongoDB. Now it sends this data to Mongo, and now it sends data to monitoring service. So basically now we have service to monitor, and in the next video we will discuss the environment for setting up the monitoring, and later we will build the monitoring in itself. Hope to see you in the next videos.